Yes, the size, exactly. So we have designed it here. We have said, okay, each word or each pair, okay, I want you to give it a dimension of what? A vector of dimension 100. So 100 numbers for each word or for each token. Okay, we simply make an instance of the model, and then we make a print function to see that, okay, we have a vocab size of 30K and an embedding dimension of 100. Okay, let's run this cell. And one important thing also about Pytorch. Okay, so when building Pytorch models, you have two options on where to run the model, where to run the training. So you can run them on the CPU or you can run them on the GPU. Now CPU would be slow, okay, if you don't have it, it would be, very slow. But if you go to the GPU, which I have here, I'm telling it, okay, device. This is a very common line of code in Pytorch models. It's simply a fail-safe. If it didn't find CUDA, you go for CPU, so it doesn't give me error. Okay. So I'm telling it, okay, I want you to use CUDA. Of course, CUDA is available, which is CUDA toolset. CUDA toolkit, sorry. CUDA toolkit is the way, CUDA is the framework NVIDIA made to communicate with GPUs, okay? Else, if you didn't find any, I want you to use the CPU, okay? And we simply need to make the model on the device. So do we need the model only on the device, whether it's CPU or CUDA? We need the model and the dataset. If you didn't put your dataset on CUDA, on the GPU, you will get an error, okay? So what you do is you put the architecture you just built. This is the architecture, guys, okay? So this is the architecture, the nn.module. You have made an instance of this model down here. Here is the instance of the model, okay? Model, this one here. And after that, you need to pass this model into the GPU, put it in the GPU. Also, the data needs to be on the GPU. After you finish training, the trained model is still on the GPU. You need to take it back to the CPU to make inference. Otherwise, you will make inference on the GPU as well. Okay? This is a very, important note on training, Pytorch models. Okay? Okay, negative sampling loss. What does that mean? Now, as you can see from the description I've said there, so we're trying to give a little bit higher score to words occurring next to each other and to give lower scores on words that are not really appearing next to each other, okay? This is a part. This is the negative sampling loss. Sorry, where did you go? Negative sampling loss, okay? Okay, and we get some negative samples. We get only 5 samples, okay? So we get only 5 negative samples randomly out of the dataset. So we take a positive example, okay? And we'll say, okay, these words should be together. And we'll take another 5 from the dataset randomly, and we will say, okay, given this context word, this should be give higher score to these ones and lower score to the other 5. Huh? Okay? Okay. Okay, train epoch. Let's explain this as well, because this train epoch is it's important. Training Pytorch models is important. Okay. So train epoch is what? What does it do? What does this function do? It takes a model, the model we just made, okay, the instance of the model, and it takes the data loader. What is the data loader? It's a very important component of Pytorch. It is responsible for feeding the data to the model. Huh? Okay. And we have the optimizer. What is the optimizer used for? SGD, yes, but optimizers, broadly speaking, huh? Optional value? Optimal value, yes, exactly. Yes, yes. We have a function, and we are trying to maximize or minimize, right? Exactly. And find the optimal value for maximizing or minimizing. And this is what we are trying to do. Okay. Of course, SGD is one of the most popular optimizers out there. And what is the criterion? This is the loss function. Okay? So I always look at it like that. I always visualize training like what someone, okay, is throwing darts at the, you know darts? Of course? Darts? Huh? Can you translate darts game? لعبة الأسهم. Huh? يعني translate it so everyone can understand.
Someone looking from the top of.
It's a game like the child game where you have on the wall here circles, and you throw darts. All right? Yes. So I visualize it as what I am the model. Okay? And basically, what happens is I throw darts. Okay? Predictions. So I throw darts away from the bullseye. So this is the middle bullseye. Okay? I throw away. Okay? And someone, which is the data, okay, is telling me, okay, go a little bit, the optimizer. Based on the data, the optimizer is telling me, okay, throw a little bit to the right. So I throw here. Now go a little bit to the down. So I throw here. Now go a little further to the down. Okay, so it guides me till I reach what? Bullseye. So I reach the middle. Okay? So as I go down from really randomly, throwing really randomly predictions, the optimizer guides me through the minimum value, which is like I'm now able to solve the task at hand. Okay? And do you understand?
I think the same thing as a person in the top of a mountain, and he wants to get down.
Excellent. Yes, exactly. SGD is the same, like you are descending the hill. Yes, exactly. Okay, so this is the loss function. Okay, and we have also the vocab size, the number of negatives. As we said, we will have one positive example with 5 randomly negatives, and we will say, okay, give this one more probability. Huh?
Number of vocab, we take it to send it to model center.
The vocab size, we will use the vocab size in the get negative examples here. Okay? Or I didn't understand your question. Can you please rephrase? Okay. Okay, so we also put the device to be CUDA. In order to train a model, we put it in the train mode. Huh? How do we put it in the train mode? Model.train. This is Pytorch. So we do model.train, okay, and then we initialize just a variable to store the total loss, okay. Now, what do is we iterate over the data loader, right? Like I told you, the data loader is responsible for feeding the data. So, what does it do? What does the data loader holds now? Target IDs and the context IDs, okay? Targets, okay, and the context like cat and the words related to the cat, okay? Exactly, 1 and 3, the bears we said, yes. Now what we do is, like I told you, we need to put everything on device, exactly. So we simply do move them to device, okay? And then optimizer.0grad. Optimizers, they store the gradients. What is the gradients? What is the gradients in deep learning? This is the rate of change of each parameter or of the weights. Huh? So what are the weights? So
how we minimize the weights to have a good prediction?
You don't minimize the weights. The optimizer does this automatically. Okay? The optimizer reduces the weight. How? Like I told you, the optimizer guides. So it changes the numbers based on the gradient. Okay?
Adjust.
It's adjust, yes.
The way to have the good, better predictions.
Exactly. Huh?
To minimize the loss.
To minimize the loss function. Okay, yes. So the optimizer we are doing here 0 grad means that If you have any gradients, please, yes, make them 0. And the gradients is what? Gradients is like the changes you are making in the model, okay? It's like you are saying the model, you are pointing here, please go a little bit down. So this change in the numerical, in the numbers, okay, is guided by what? By the gradients, okay? What is the rate of a change? Should I move 0.5 or 0.3 or 0.2? Who decides? The optimizer, based on the loss function. How far away I am from the correct prediction. Huh?
This is good.
Huh?
Descente gradient. What's that? In French, the descente gradient.
Distance gradient?
Yes, in French.
Yes, exactly. Yes, differentiation. This is differentiation. Exactly. Yes. Okay. Now, we'll just get also the negative samples, put them on device, positive samples, all of that. Where is the criterion? Yes, this is important. Oh yes, let me just search for the criterion. We will design it later on. We have, this is also a little bit an advanced concept, working with different models, okay? When you are specifically working with a specific task, one of the things you need to do as a researcher is as well think about what is my loss function. If it's not a classification, so cross entropy loss, okay, you know cross entropy loss? And the binary cross entropy, which is for binary classification problems. Huh?
Yeah.
Okay, yes, so
If you have a classification, multi-classification.
cross entropy loss.
Yeah, we have.
Yeah, yes, cross entropy loss for multi-classification. Okay, so if it's not that case, if it's not a simple task that you know that this fits this kind of loss function, you would have to make your own loss function. And this is the case here. Okay, it's a little bit advanced loss function. We are giving a higher score to positive ones, on the contrary for negative ones. Okay, so it's a little bit also advanced also. And we simply, okay, say loss dot backward and optimizer dot step means that, okay, take a step towards minimizing the loss. Okay, which means take a step towards the right solution. Make that gradient descent. Okay, descend the hill or reach your target. All of these. Okay, well, some training settings, we say, okay, batch size 128, which means that in each time step, I want you to pass 128 example to the model. Okay, and what is the learning rate? Learning rate is the update values. Okay, you don't want the update values to be very big. Okay, because why? Because you will have a problem. You will have a problem. Not overfitting, oscillation. Overfitting can be reduced by early stopping. Overfitting can be reduced by early stopping. But in our case, if you make the learning rate a little bit large, what will happen is it will oscillate. Let me explain oscillation with a drawing. Okay. So Professor Muhammad just explained that this is gradient descent. Okay, you are at some point and you are trying to reach here the minimum. Okay, which means that your model is performing very well. Okay, now what is the learning rate? Learning rate is how much do I move each step. You see this? What happened here?
We missed the
Oscillation. Oscillation. It will keep oscillating because it's trying to get in the middle. It will keep oscillation. Okay?
Now we have to change the learning rate to get more.
Not to get more. You have two options. whether to start with a small learning rate and just keep keep watching the loss. If you notice that it starts to oscillate, you need to stop. But this is not really practical. You get this with a lot of experience and experiments. You know that, okay, this is oscillation.
You can adjust the learning rate in function of the...
There is a smarter way. What called what?
Adjust the learning rate in function
Adjust the learning rate. This is called what? This is called learning rate schedulers. Learning rate schedulers. One of the most famous is cosine. Let me search about it. Cosine scheduler with warm up. Yes, cosine. Yes, cosine scheduler. Yes. Cosine annealing, yes. Cosine annealing worm is, I think this is the one. So, if I think I have the book here. Let me show it to you. Anything? Inside deep learning. Okay, this is from a book I like very much. It's called Inside Deep Learning. I even took some diagrams and texts from this book to our course. Okay, and I really like the book. It's one of the books that changed how I think about deep learning and AI. Okay, it's called Inside Deep Learning. And the author name was what? I don't really remember now. Okay, no problem. But learning rate schedulers. It's one of the more new training techniques or modern training techniques. Okay.